In the introduction topic itself, we have learned all these regarding what is matter, what are the elements, the terms we are going to learn regarding matter and types of mixtures, all those things we have learned already, I think. So if we consider matter, matter is that which is having a certain mass and which can occupy space. So anything which occupies space and has mass is called as what? Matter. ಈಗ matter ಅಂತ consider ಮಾಡಿದಾಗ matter ಅಲ್ಲಿ three states of matter mainly we can consider. Which are those three states of matter? So solid, liquid and gas. So we can just classify this matter into three types. Which are those? Solid and another one is gas. So you can just distinguish the substance as solids or liquids or gases with respect to their closeness of the molecules of the atoms. In case of solids, you can find there is a close and compact arrangement of the molecules as known earlier. And in case of liquid, the molecules are loosely bound, they are loosely arranged and they don't have definite shape. And in case of gas, how much the space is provided, that much space is occupied by those molecules. They are far away from each other as far as possible. Here, these three states of matter actually depends on the intermolecular forces of attraction. For the association of molecules, either solids, liquid or gases, we require certain forces of attraction. So that intermolecular forces of attractions and repulsion, that will be well explained by the scientist van der Waals. So in the honor of that scientist, they are considering that forces of attraction between these type of molecules will be said to be van der Waals forces. Van der Waals forces. And now, if you come for particularly the gaseous state, in this chapter, we are more focusing on the gaseous state. And now, once you consider this gaseous states of matter, now we can just consider here there are different types of gases. As you know, air is a mixture of gases. So, in addition to oxygen, there will be presence of many other gases. Even you can find a trace quantity of the noble gases like helium, neon, argon, krypton, xenon, like that. And if we consider the molecules, the nature of the molecule, either they are said to be having similar type of the atoms or different type of the atoms. So now if we consider hydrogen, hydrogen formula is we are going to write it as H2. That molecule of hydrogen is made up of identical atoms. That is hydrogen, another one is also hydrogen. And if we consider another example, nitrogen. Nitrogen is also consisting of, so ಇಲ್ಲಿ ಎರಡು atoms nitrogen identical ಇದ್ದಾಗ ಅದನ್ನು elementary state ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So homoatomic state with respect to these molecules. And even if we consider oxygen, that is also containing similar type of the atoms, isn't it? But now if we consider, so if hydrogen chloride is in gaseous state, in that state hydrogen is different and chlorine is different. Now we can easily make out the difference. They are homoatomic in state. These are, it is heteroatomic in state. So now, whether they are homoatomic molecules or heteroatomic molecules, so it also differs with respect to their forces of attraction. So now we can consider any neutral atom that is consisting of central positively charged nucleus and surrounded by many orbits which are containing different number of electrons, isn't it? That means there is both positive charge as well as a negative charge in an atom, but there is no such polarity within the neutral state of the atom. Now, here how we are going to get the association of different types of atoms? So that is caused due to that van der Waals forces of attraction. But now, if you specifically consider this van der Waals forces of attraction, we can divide this van der Waals forces of attraction as further as very first important type of van der Waals forces of attraction as London forces or dispersion forces. London forces or dispersion forces. Next, if we consider next type of force of attraction, that is in terms of van der Waals force, dipole forces. Dipole forces. And another type is dipole-induced dipole forces. So majorly we can classify this van der Waals forces of attraction as London forces. It is also called as dispersion forces, and then dipole forces, and then dipole-induced dipole forces. The different types of forces may depend on that. It is depending on the nature of type of the atoms that we are going to consider. Got it? And now, very first, if you start with, which is that first force, that is London forces. So usually if we consider any particular atom, even the atom of the neutral state, there is uniform distribution of the electrons all over the nucleus. So there is no such a positive pole and negative pole. Electrons alla illi one kade ide, right side ide, matte protons alla left side ide anta heli baralla, isn't it? So there is a stability with respect to this atom. Now, once you consider atom, for example, take a helium example, it is a helium atom. It is just going closer to another helium atom. These two are similar atoms. Illi polarity illa, idrallu polarity illa. Yake? They are same element, that is helium. Got it? Is an atom A, the atom B anta consider madabodu. But here we are taking that similar type of atoms. So now, if we consider the similar type of atoms, there is no such polarity like negative pole and positive pole here, isn't it? But once they come closer together, there is a possibility one will undergo that is, it will undergo by itself polarization. So here it will gain positive charge at the one end. Again, atom almost electrons, that electron density will be towards the opposite direction to that of the positive. Now, what happens here? Once you consider that is not complete charge separation, you don't assume that 100% positive here, 100% negative, not like that. Polarity means only partial distribution of the negative electrons to one side and positive towards the another side. Electron density one to polally jasti agutte, it is said to be polar, temporary. Andre polarity is actually. So it is just having temporary polarity. Once it is in interaction with the another similar type of atom consumer, again automatically ಇಲ್ಲಿ negative pole ಇದ್ದಲ್ಲ opposite poles attract together ಅಂತ ಗೊತ್ತಿದೆ. ಹಾಗೇನಾಗುತ್ತೆ negative electron density will be closer or positive electron density will be closer to one. It is absolutely the negative ಆದಾಗ here positive will get attracted towards that electron density, and opposite to this there will be polarity. ಅದರಲ್ಲಿ ಏನಾಗುತ್ತೆ negative polarity is towards right side, and also negative polarity is towards right side. ಈಗ ಈ ಎರಡು atoms ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಪೋಲ್ ಇದೆ, ನೆಗೆಟಿವ್ ಪೋಲ್ ಇದೆ. Absolutely you can remember force of attraction exists between opposite poles, that is opposite charges means positive and negative. As that such force of attraction will be existing between non-polar attraction or attractive forces between non-polar molecules. Non-polar molecules will be considered as, that is, London forces or dispersion forces. Agar London forces and dispersion forces anta bandaga, you should remember that is similar type of the atoms. Example, hydrogen molecule, oxygen molecule, and even you can consider the noble gases like helium, neon, etc. Got it? That is regarding very first type of London forces or dispersion forces. Very simple. London forces andre eno, dispersion forces andre eno. These are the force of attraction existing between non-polar molecules. Got it? And now, if we go for dipole forces, here, if we say forces, ಈಗ ನೇಮ್ ಇಲ್ಲೇ ನೋಡ್ಕೊಳ್ಳಿ, ಈಗ ಲಾಜಿಕ್ ಏನು ಅಂತ ಅರ್ಥ ಆಯ್ತು. ಇಲ್ಲಿ ಡೈಪೋಲ್ ಡೈಪೋಲರ್ ಆದ್ರೆ ಎರಡರಲ್ಲೂ ಪರ್ಮನೆಂಟ್ ಡೈಪೋಲರ್ ಇದೆ. ಇಲ್ಲಿ ಡೈಪೋಲ್ ಇನ್ನೊಂದು ಇಂಡ್ಯೂಸ್ಡ್ ಡೈಪೋಲ್. ಈಗ ನೀವೇ ಯೋಚನೆ ಮಾಡಬಹುದು. Dipole. One molecule is said to be having polarity. One molecule is said to be having polarity. Got it? And another molecule is having no polarity. For example, like HCl, another one is hydrogen. We can consider. And now we can just say that here hydrogen fluoride is heteroatomic molecule. It is homoatomic molecule. It is element. It is not element. So here, now if we consider, this is having positive pole and chlorine is having negative pole. Hydrogen, no polarity. But what happens when the hetero molecules come closer to the element, this molecule which is homoatomic in state? It will induce this molecule to get polarity. Well, polarity is there, but even polarity is there. But once it comes closer to it, it induces polarity on this molecule. Here, the negative pole iddaga, it attracts the positive pole. And here, it will get negative pole. There is a shifting of the electrons slightly towards this hydrogen atom, that is negative pole. Alli electron shift agutte anta artha. Negative value irutte, alli electron, bonded electron irutte, that is slightly moving towards that more electronegative atoms. ಅದರಲ್ಲಿ ಏನಾಗುತ್ತೆ, polarity is actually equal ಆಗಿ distribute ಆಗಿರುತ್ತೆ electrons, but because of inducing from the heteroatomic molecule, here it is gaining partial positive charge and another one is getting partial negative charge. Hence there is a existence of force of van der Waals forces of attraction between the dipolar molecule and non-polar molecule. Got it? Hence, what is this dipole-induced dipole forces? These are the forces of attraction between dipole and non-polar molecule. Dipole and non-polar molecule. Got it? These are the three types of van der Waals forces with respect to the existence of certain forces of attraction, including along with that repulsion in between different types of the molecules. Got it? And once you know there are three types of the van der Waals force of attraction, that is London forces or dispersion forces, then dipole-dipole forces, then dipole-induced dipole forces. There are three types of van der Waals forces are type. Next, now if we consider, are there any factors which influence this forces of attraction? And what factors this van der Waals forces of attraction depends? Now, factors affecting van der Waals forces. It's a very simple thing. So very first, if we consider, if there is increase in the number of electrons in any given set of molecule, ಹಾಗೇನಾಗುತ್ತೆ, ನಾರ್ಮಲ್ ಆಗಿ ಎಲ್ಲಿ ನಿಮಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ ಕೊಟ್ಟಿರುವಂತಹ ಮಾಲಿಕ್ಯೂಲ್ ಅಥವಾ ಆಟಮ್ ಅಲ್ಲಿ, there you can consider the more number of electrons, more is the electron density towards one pole. Hence it will increase more charge on one particular pole. ಎಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, electron density ಜಾಸ್ತಿ ಆಗೋದ್ರಿಂದ ಅಲ್ಲಿ polarity ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Therefore, here that forces, van der Waals forces, increases with increase in number of electrons. ಗೊತ್ತಾಯ್ತಲ್ವಾ? So electrons ಜಾಸ್ತಿ ಆದಷ್ಟು polarity ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಆಗ van der Waals forces ಕೂಡ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Then it also depends on size of the molecule or the atoms, what you can consider. Normally ಒಂದು ಆಟಮ್ ಸೈಜ್ ತುಂಬಾ ಚಿಕ್ಕದಾದ್ರೆ polarity ತುಂಬಾ ಕಡಿಮೆ, the possibility for polarity is less. ಅದೇ ಒಂದು ಆಟಮ್ ಸೈಜ್ ದೊಡ್ಡದಾದ್ರೆ it is easy to segregate the positive pole and the negative pole. That is why van der Waals forces increases with increase in size, with increasing size of molecules, with increasing size of molecules. Got it? That it is depending on the number of electrons as well as it is depending on the size of the molecules. Then if we come for temperature. So as there is increase in temperature, because of the molecules will get more and more energy, they will move far away from each other. So temperature ಜಾಸ್ತಿ ಮಾಡಿದಾಗ energetic ಆದ molecules ದೂರ ಹೋಗಕ್ಕೆ try ಮಾಡುತ್ತೆ. Hence there will be decrease or it decreases. Van der Waals force decreases with increase in temperature. So temperature ಕಡಿಮೆ ಮಾಡಿದಷ್ಟು forces ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Temperature ಜಾಸ್ತಿ ಮಾಡಿದಷ್ಟು van der Waals forces ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಆಗುತ್ತೆ. Got it? And what about the last important factor? That is also pressure. ಹಾಗಾದ್ರೆ pressure ಹೇಗೆ affect ಮಾಡುತ್ತೆ? ನಾರ್ಮಲಿ ನಿಮ್ಮ LPG ಗ್ಯಾಸ್ ಸಿಲಿಂಡರ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿದಾಗ ತುಂಬಾ ಹೈ ಪ್ರೆಷರ್ ಅಲ್ಲಿ ನಾವು ಕಂಪ್ರೆಸ್ ಮಾಡಿರ್ತೀವಿ. ಅದೇ ನೀವು ಮೇಲೆ ನಾಬ್ನ ಓಪನ್ ಮಾಡಿದ ತಕ್ಷಣ all the gaseous molecules which were in liquid state in the cylinder, they will oozing out in the form of gas, isn't it? That means pressure ಜಾಸ್ತಿ ಆದಾಗ force of attraction ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Van der Waals forces increases. Van der Waals forces increases with increase in pressure. With increase in pressure. Decreases. I had given it is correct. Decreases with increase in temperature. But here with respect to pressure, directly proportional. If you increase the pressure, increase in Van der Waals forces. If you decrease the pressure, decrease in Van der Waals forces. But with respect to temperature, it is inversely proportional. So that is regarding the very first topic in this chapter, that is states of matter. We have learned regarding types of Van der Waals forces with different examples, and also with regarding the factors which affect the Van der Waals forces. So we can continue the next topic in the next live class. So have a good day.